So hello friends, today we are going to see the introduction to finite element analysis, better to be known as FEA. FEA is a powerful engineering tool to simulate real world performance. So we are going to see what is FEA, so what are the key ideas in FEA, the FEA processes, why use FEA, types of FEA analysis, and where the FEA is used in different industries that we are going to see. So first of all, I'll start with FEA as if you don't know nothing about FEA. If you know nothing about FEA, so this way I am going to start the FEA. So as a mechanical engineers, many students and industrial engineers knows the FEA, but I will start as if I am telling the kid what is the FEA and how it is going to be used uh, in different industries. So FEA is a kind of a tool where we can apply our loads, boundary condition, temperature, pressure, vibration, forces, heat, and we are going to see the virtually how the component or product is going to behave uh, for these different conditions of loads, heat, pressure, and etc. So FEA is a kind of a tool, a virtual calculation or virtual simulation tool. It shows how these things behave across the product or across the component. So that is the thing about the FEA. So like physical things, we'll apply the loads to the physical things and we check the physical things whether they are going to be failed or not. So similarly here we are going to check these things in the computers and softwares. So that is the only purpose of FEA. And to draw the results and conclusions from this analysis. So that's why is FEA is used. So this is like a basic kind of a information or introduction of the FEA. If I'm going to tell to any kid what is FEA, so we should teach the FEA in this kind of way. So this is the basic information and introduction to the FEA. So I'll start with the FEA. Like FEA turns a design into reality. So I will come to that point how the FEA turns design into a reality. I have just created a flashy kind of an introduction slides from by using ChatGPT, and so this slide is not created by me. I just given prompt to the ChatGPT, and ChatGPT has created this kind of image. So it looks a more flashy kind of image, and it created an interest into the students and engineers to learn the FEA. So that's why I have worked so much on the slides uh, and giving different prompts to the ChatGPT to create a kind of a slide to teach the engineers and students about the FEA. So I'll start with the FEA. So what is FEA? It is kind of a computer-based numerical technique used to predict how a product reacts to real world force, vibration, heat, and other physical effects. So FEA kind of a numerical technique. So by using mathematics, we designed the softwares in such a way that we coded all our mathematical equations and formulas into the software, and then we apply the loads, and then the software gives us a result like a real world results for the forces, vibration, heat, and other physical effects. So it is a kind of an effort to it is kind of an effort to draw the real world scenario into a virtual thing. So kind of a software, you can say that. So that is the function of FEA, to reduce the count of the prototypes, to reduce the physical prototypes, and because the physical prototype stock takes too much cost for the engineering design. So then I'm coming to the different points in the FEA. So we'll come to the first point, the key ideas in the FEA. So key ideas is in the FEA is like you can see that different kind of icons and images over here. So uh, we are going to start with the first image. So break a complex structure into a small piece called element. So we take some component. Okay, so we break the component into a, we suppose if we take some component, a kind of a plate, imagine, and we break that plate into a small elements, and then we apply the loads to the element, apply material, loads and boundary conditions to the element, and we check how the we check the unknown, we check the values, we check our required values, uh, how it is going to be behave. So suppose if I take a plate, and if I'll just show you. Suppose if I take a plate with a hole on it, and I have applied elements to the plate, suppose a square element. I divide this plate with just the small elements, and I applied the load to the element, to the plate, and I will check how the loads and stresses are going to be introduced into the plate. So this will give us a better idea how the plate will behave. So instead of doing a physical prototype for multiple times with different load condition, we can apply the same thing into the virtual world, like in the software, and we combine these different loads and stresses generating in the plate, and we can derive our conclusions from it. So that is the important thing, or the key idea behind the FEA. So breaks a complex structure into a small piece called elements, apply material properties, load and boundary conditions, solve for unknown displacement, stresses, strain, etc., etc. Combine the results to understand the behavior of the entire structure. So yeah, we apply the materials to the plate, and then we give our loading conditions. So what are the loads for that plate? And then we solve for the required stresses and strains. So we have come to know the what stresses and strain is going to be generated into the plate, whether the plate is whether the plate is uh, safe, or it can sustain the loads. So that is going to things we are going to see in the FEA. So behind this, you can see that a aircraft structure. So aircraft structures are like one of the most uh, complex and most you can say that means a lot of loads are coming onto the aircraft when aircraft is flying. You have weight is applied on the aircraft. So suppose your aircraft is flying. So in the aircraft, you have different loads are acting on the aircraft. So its own weight, gravity, and its own weight is applied on the aircraft. Then aerodynamic force is going to be applied on the aircraft. So different, also the drag is going to be produced inside the aircraft. So different kind of structural loads are going to be applied on the aircrafts, and aircraft wings has to sustain these kind of loads. So that's why I put this image on the introductions of the FEA. So yeah, we are going to see the different kind of loads and everything. We are going to dive deep into these things, but just start with the basic things first. So so once I finished the key ideas, so the key ideas I just talked to you, like stresses. We first divide the plate into the small element, then we applied the load to it, and then we solved our solve for our uh, required results. So suppose if I wanted to know the stresses, pressure, heat, temperature inside the plate, so we are going to check uh, what are the things getting generated after our boundary condition and our after acting our loads or heat or any kind of inputs, and we will get the outputs. So this is the first thing of the key ideas in the FEA. So then the next process, no, the next thing about the in FEA is why you use FEA. Okay, so why to use FEA is the first is reduce physical prototypes and testing cost. So suppose if I wanted to check this aircraft wing, whether this wing will sustain its load, uh, aerodynamic pressure, its own weight, and other load from the aircraft which is getting transferred to this wing. So different kind of loads are getting uh, applied on this aircraft structure. So suppose if I wanted to check that structure, so it is very costly to create a prototype and apply the load physically on the different part of the wings, and then test the wings whether it is getting failed or not. So suppose like if I applied some X tons of load on the aircraft wing, and the wing uh, suppose the wings gets filled, so then I have to check whether, suppose if I applied then X tons of load and it is getting filled, so then again I have to bring the new wing, and I have to reduce this X value, and then again check the wing whether it is getting failed or not. And then again, suppose again it is getting failed, then again I have to reduce the amount of load is getting applied on the wing. So for the multiple iterations, I have to create a multiple prototypes and again check for the multiple loading condition. So for product like this big kind of a product, it is so such a big kind of uh, component or product like in aircraft. It is getting very costly to check for different kind of loads, and again making multiple kind of components to uh, to check our the loading conditions whether it is getting passed or not. So that is not possible for the companies, and companies will go bankrupt if they goes for this kind of approach. So in that case, the FEA is going to be a very helpful, where we can create a CAD model into the software, and we can apply the loads with multiple times, and we can perform iterations. So in the first iteration, suppose if I applied 100 100 kg of load, then I'll check how this aircraft wing is going to be behave. So imagine it is a very small aircraft and not that big aircraft. So 100 kg of load. So if it is not getting failed, so then yeah, it is okay. The aircraft is passed for the 100 kg. Suppose if I applied again 200 kg of load, it also shows, yeah, the aircraft wing is not getting failed. But suppose if I applied again 350 kg of load, and the wing is getting failed, so then I have to again check that whether it is getting failed for 350 or 300 or 325 or 290. So this way I can perform multiple iterations, and I'll come to know the exact value where the wing is getting failed. So in this way I don't need to create a physical prototype. I can just do a CAD simulation, and then again I get some results like, so yeah, so to a 90 kg the wing is getting failed. So I will create a physical prototype of the wing, and then I will apply 290 kg of load to the wing, and I will check in reality whether it is getting failed for the exact 290, or whether it is going to be failed at maybe 320 or 270 or 250. This way I'll come to know that at, at what at what load this aircraft wing is going to be failed. So this kind of approach, where we don't need to uh, create a multiple prototype, we can do this once in the CAD simulation, and once we got the exact result, so we can check our FEA values with the real world values. So this way it reduces the prototype cost and the testing cost for the component. So yeah, another point is predict performance early in the design stage. So what is mean by the predict performance early in the design stage? So I'll just show you. Suppose if I wanted to design this structure, this aircraft structure, and I wanted to add the different kind of, you can see the rails. Okay, so these kind of horizontal rails, vertical rails and horizontal rails. Suppose if I'm doing the assembly of these different rails, and suppose if I wanted to add only 6 rails, suppose 1, 2, 3, 4, 5, 6. So I will what I will do, I will only add first 6 rails and 2 horizontal rails. Okay, so this horizontal kind of a bar or structure I will add, and I will perform the FEA. I will perform the analysis. I will apply the load and I will check the values. Suppose the wing is getting failed, what I can do, I can add some more rails. I can make the wing more stiffer. So again I will check, I will add some more values, and again I will add more rails and or more structures or more beams kind of a thing. So I will check that whether it is getting failed or not. So this kind of approach I can predict early in the design stage. So what while designing and CAD modeling and um, creating a structure, so I can check side by side whether my design will get passed for the how many rails or how many horizontal and vertical kind of uh, you can say what you can say, there's a rail or a rail or a structure kind of a thing. So I can check that I can check the performance in the early design stage. So that is the point. That is the second point here, that it predicts performance early in the design stage. So another point is improves the product reliability and safety. So what do you mean by improve the product reliability and safety? So while doing the multiple iterations, suppose if I'm doing the multiple iterations for this aircraft wing, so here I can note that for my 100 kg wing, the displacement of my wing is maybe a 5 centimeter or 5, yeah, so 5 centimeter my wings can get bent, or maybe you can say 2 centimeter. It's very much. So then again, if I give the load and again I check the displacement, how my wings is going to be bent. So this way I have the data for the how many loads, how many different values of the loads my displacement is going to be changed. So from that I got more data, I got more information. I'm going to know so how this each and every part is going to behave under the different loading condition, where the stress is getting generated, how the part is going to be displaced. So all these kind of things I come to know virtually while using FEA. So that improves my component, correct? So I come to know that at what point and at what regions of the structure the stress is going to be more, and at what regions of the structures where the stress is going to be less. As in the image you can see that where you can see that here the red portion, you can see that where the stress is more, and then stress is going to be reduced gradually over here, and then here there is not much that stretch. So that's why it is showing a blue region. So red region, you can say that it is kind of a dangerous zone. So this way we can come to know the product reliability and safety. So with multiple iteration, with different kind of loading condition, boundary conditions, we come to know how the product is going to behave or how the component is going to behave. Okay, so then coming to the next point, optimize design for strength, weight, and durability. Yeah, I just talked about. So optimize strength means, yeah, so different loading condition, different stress conditions, different vibration conditions. So all these kind of things with different heat and temperatures. So all these kind of things we can check whether the design is durable or not. So saves time, and the next point is saves times and development cost. So as you know that if we are going to if you are going to iterate the loading condition for the 5 different loads, So then we have to apply the loads 5 times physically. So it will take a lot of time and cost and technicians to remove the one load, then again to the apply load, again to apply another load, and again going to remove that load 200 kg and again apply to the 350 kg. So that kind of a time consuming process can be reduced from lab to the virtual thing. So that is the thing behind the saves times and development cost.